Okay, hello everyone. I welcomes to all in our lecture series on mathematical physics, that is your core paper 8, belongs to 4th semester BSc Physics on our syllabus CBCS model. This is your lecture number 4. In our last lecture we have been discussed De Moivre's theorem and corresponding numericals also we have been discussed. In this class we are going to discuss roots of complex numbers and corresponding numericals also we are going to discuss with the help of De Moivre's theorem. Okay, so let's start. Before we are going to discuss roots of complex number, first we are going to discuss cube roots of unity. Okay, to find cube roots of unity, consider this equation, that is your x cube minus 1 equal to 0. That implies x cube equal to 1, x equal to 1 to the power 1 by 3. That means from the equation, this equation, we can understood that this equation has 3 roots. Okay, so to find the 3 roots by using De Moivre's theorem, this is the procedure. You just watch. 1 to the power 1 by 3. 1 can be written as cos 0 plus I sin 0, because sin 0 is your 0, cos 0 1. So this is nothing but 1 itself. Here we have to find out 3 roots. So this cos 0 plus I sin 0, that means 1 in general can be written as cos 2n pi plus I sin 2n pi. Here n can be 0, 1, 2, 3, 4, any integer. Because if I'm going to put 0 over here, then we can found cos 0 I sin 0. If we have to put 1, this will be cos 2 pi I sin 2 pi, sin 2 pi will be 0, cos 2 pi again 1. If we have to put 2 over here, cos 4 pi 1, sin 4 pi 0. 3, if we have to put, it will be cos 6 pi, sin 6 pi will be 0, cos 6 pi again 1. But as we have to find out 3 roots, only for that, for this case, we have to consider n will be equal to 0, 1, 2. For 0, first root. For n equal to 1, we can found second root. For n equal to 2, we can found third root. For this equation, that is your cos 2n pi plus I sin n pi to the power 1 by 3 can be written as this one by using DMT. This 1 by 3 will be multiplied with 2n pi and here 2n pi. So hence we found x equal to cos 2n pi by 3 plus I sin 2n pi by 3. So this is the general equation we found, from which we can evaluate 3 roots by substituting n value 0, 1, 2. For n equal to 0, we can get the first root. For n equal to 0, this x value will be how much? Here 0, if we have to put, this will be cos 0 plus I sin 0. Sin 0 will be 0, cos 0 1. So we found first root equal to 1. Then for second root, we have to consider n equal to 1. Put n equal to 1 over here. This will be cos 2 pi by 3 plus I sin 2 pi by 3. Cos 2 pi by 3 plus I sin 2 pi by 3. Pi by 3 is your 60 degree. Okay, pi by 3 is your 60 degree. This is your 60 degree. Pi by 3. Then 2 pi by 3 means 120 degree. That means this angle will be in the second quadrant. This is your positive real axis. So 2 pi by 3 will be in the second quadrant. In the second quadrant, cos 2 pi by 3 is the minus. Sin we can get, sin will be plus. So cos 2 pi by 3 or cos pi by 3 in the second quadrant, value will be minus 1 by 2. Sin 2 pi by 3 or sin pi by 3 in the second quadrant, value will be root 3 by 2. Hence we found second root when we put n equal to 1 will be equal to how much? Minus 1 by 2 plus I root 3 by 2. This is your second root. Now for n equal to 2, if we are going to put over here in this equation, we can found cos 4 pi by 3 plus I sin 4 pi by 3. So here 4 pi by 3 will be lie in the third quadrant. In the third quadrant, cos and sin both are negative. So hence x3, that means third root will be equal to how much? Minus 1 by 2 minus I root 3 by 2. So this is the third root. First root we found 1. Second root we found minus 1 by 2 plus I root 3 by 2. Third root we found minus 1 by 2 minus I root 3 by 2. Okay. Now it can be easily found that x3, that means third root, here third root will be equal to square of the second root. Here we can prove, you can also check in your rough, that x2 we found that minus 1 by 2 plus I root 3 by 2, right? If we are going to consider x square, that means minus 1 by 2 plus I root 3 by 2 whole square, right? So this will be minus 1 by 2 square plus, this is in the form of a plus b whole square, okay? I root 3 by 2 whole square plus 2 into a means 1 by 2, b means I root 3 by 2. So here 1 by 2 minus 1 by 2 whole square is your 1 by 4 plus here I square root 3 by 2. It will be minus of 3 by 4. Here 2 got cancelled and we found minus I root 3 by 2. So here 1 by 4 minus root 3 by 4 minus I by root 3 by 2. So here minus 1 by 4 minus 3 by 4 is nothing but minus 1 by 2, because this will be 2 by 4. 2 by 4 means 1 by 2 minus I root 3 by 2. So this is nothing but your x3. So here we found square of the second root is your third root. Same thing it has been written. In general, in all books, x2, that means second root is denoted as omega, and third root is denoted as obviously omega square, because third root is nothing but square of the second root. If second root will be denoted as omega, third root will be omega square. Also, it can be found that addition of three roots, that means first root is your 1, second root value is this one, third root is this one. If we have to add these three roots, we can found 0. Here you can see that if you have to add this 1 plus minus 1 by 2 plus root 3 plus I root 3 by 2, here minus 1 by 2. So if I will add, this will be minus 1 by 2 and here 1 by minus 1 by 2. This will be minus 1, here 1. Got cancelled. Now here plus I root 3 by 2 minus I root 3 by 2 also will be got cancelled. So we can found addition of three roots, that means 1 plus omega square will be equal to 0. Similarly, you can found, if you can do in a rough also, you can found that 1 into omega square, that means the multiplication of these three roots will be equal to 1. Here you can see 1 into omega square is nothing but omega cube will be equal to 1. So I suggest to all of you that you just remember these two results, which are essential to solve the numericals. Now we are going to represent the cube roots. Here we found the three roots. Now we are going to represent the three roots, that means cube roots, three cube roots of unity on complex or argand plane. So we know that this is your positive real axis, this is your imaginary axis. So x1, that means first root we found 1. First root we found 1. So 1 will be, suppose here, this length suppose 1. Okay. Now second root we found minus 1 by 2 plus I root 3 by 2. That means this number or the real part and imaginary part lie in the second quadrant. So the second root will be here, will be in the second quadrant, and it will make an angle 120 degree with x-axis, right? Third root, both the values are negative, that means it will lie in the third quadrant. It will be better if I will extend this one, x-axis, positive real axis. So this will be in the what, third quadrant, and we can found this length also 1, this length also 1. So hence these three roots will be lie on the circle, or we can say that these three roots are the vertices of a equilateral triangle. Here you can see that suppose we are going to consider second root. Second root is your minus 1 by 2 plus I root 3 by 2 minus 1 by 2 plus I root 3 by 2. Now the modulus of the second root, modulus of the second root is your minus 1 by 2 square plus root 3 by 2 square root over, which will be equal to how much, 1 by 4 plus 3 by 4 root over is nothing but 1. That means this length will be, the value will be 1, and this length also will be 1, right? Now we are going to go for two questions based upon this cube roots of unity. The question number 23. See, in our last class up to 22 question number we have been solved, 22 number. we solved, we discussed up to 22 number question, so hence it is your 23rd. The question is, find out the value of 1 minus omega to the power 6, where omega is the cube root of unit. We know that 1 plus omega square equal to 0. That means this expression. That implies 1 plus omega square will be minus omega, right? Now, the question is given that 1 minus omega to the 6. 1 minus omega to the 6 can be written as 1 minus omega whole square to the power 3. That implies 1 minus omega to the 6. Here, this is in the form of a minus b square. So, it will be written as 1 plus omega square minus 2 omega to the power 3. Already 3 is there, right? So, 1 plus omega square is nothing but minus omega. So, instead of 1 plus omega square, we can write minus omega and here minus 2 omega to the power whole to the power 3. This will be minus 3 omega to the power 3. Minus 3 to the power 3 is nothing but minus 27, and this will be omega q. Omega q is nothing but 1. So we have to substitute. Instead of omega q will be 1. We found the answer of this question, 1 minus omega whole to the power 6 will be equal to minus 27 is the answer. Now second question is question number 24. If omega is the cube root of unity, then show that 1 plus omega minus omega square whole into 1 minus omega plus omega square equal to 4. I left this question for you and you have to do by yourself. I'm going to give you somewhat hints for this one. That means it's simple. You just multiply this one with this one and use these two expressions. You can easily find the answer will be equal to 4. Okay. Now we are going to go for next question. That is question number 25. Question number 25 is if omega is cube root of unity, then find the value of 1 plus omega into 1 plus omega square into 1 plus omega to the power 4 into 1 plus omega to the power 8 up to 2n factors. So to solve this question, first we have to consider these two expressions. Whatever we found, that is your omega plus omega, 1 plus omega square, that means addition of 3 roots equal to 0, and omega q equal to 1, that already we have been found. Here from this expression we can find 1 plus omega equal to omega square and 1 plus omega square equal to minus omega. Now the question is given this one, what will be the value of this one? We have to find out. So this is the question. Here you can see 1 plus omega. Instead of 1 plus omega, we can substitute minus omega square. 1 plus omega square. Instead of 1 plus omega square, we can substitute minus omega. 1 plus omega to the power 4. Omega to the power 4 can be written as omega q into omega. Omega to the power 8 can be written as, here you can see, omega q to the power 2 into omega square. This will be what? This will be the value is your omega to the power 6 into omega to the power 2. That means omega to the power 8. So omega to the power 6 can be written as omega q to the power 2 into omega square. Likewise, up to 2n factors we can write. Here you can see minus omega square minus omega is nothing but omega q. Here omega q value is your 1. So this term will be 1 plus omega. Omega q value is your 1. So this term will be 1 plus omega square. Up to 2n factor we can write like this. Omega q is nothing but 1. 1 plus omega value is how much? Minus omega square. We can substitute. 1 plus omega square value is your minus omega. Here we can substitute. Up to 2n factor we can do like this. Minus omega square minus omega will be omega q. Omega q value is your 1. If value we put, then we can get 1. So here, as we are going to move up to even factors, then even number of factors, then at last we can found 1. Okay, here we consider four terms. So obviously it will be even terms. If we are going to consider 2n factors, that means even terms we have to consider. Here 4 terms we consider, 1 we found. 6 terms if we are going to consider, then again also we can found 1. Likewise, if we are going to consider 2n factors, also we can get the answer will be 1. Now question number 6. Using de Moivre's theorem, solve x to the power 7 minus 1 equal to 0. From this equation, we can easily understood that for this equation we have to find out 7 roots because power is 7. How we are going to find out? Here you can see x to the power 7 minus 1 equal to 0 is the given equation in the question. So x to the power 7 will be equal to 1. 1 instead of 1 we can write cos 0 plus I sin 0. Already this type of things we have been discussed just before. uh, that implies x to the power 7. In general, this cos 0 plus I sin 0 can be written as cos 2n pi plus I sin 2n pi, because if we have to substitute any value of n 0 1 2 3 4 5 6, any number we are going to consider, then cos 2n pi will be 1, sin 2n pi will be 0, because sin any pi we know that the value will be 0. So cos 2n pi, that means odd pi, sorry, even pi, cos even pi will be equal to 1, that we know. So in general this one can be written as this, in this format, cos 2n pi plus I sin 2n pi. Hence that implies x will be equal to cos 2n pi plus I sin 2n pi whole to the power 1 by 7. Here 7 is there, so power will be 1 by 7. That means 7th root we have to find out. So to find out the 7 roots, we have to consider the n values are 0, 1, 2, 3, 4, 5, 6. For these n values, we can get the 7 roots. Here you can see 1, 2, 3, 4, 5, 6, 7. 7 roots. N equal to 0 first root, n equal to 6 seventh root. One by one we are going to evaluate. For n equal to 0, here you have to substitute. Okay. For n equal to 0, this will be cos 0 plus I sin 0 to the this for here. Here I forgot one thing. If it will be this one, then this can be written as cos 2n pi by 7 plus I sin 2n pi by 7 by using DMT, right? So to find out the 7 roots, one by one number we have to substitute in this equation. For first root, we are going to consider n equal to 0. So you just put n equal to 0 over here. This equation will be cos 0 plus I sin 0. The value will be 1. For second root, we have to consider n equal to 1. N equal to 1, you just substitute here and here x2. That means second root will be cos 2 pi by 7 plus I sin 2 pi by 7. For third root, that means x3, we have to consider n equal to 2. If we have to substitute n equal to 2 over here, this will be cos 4 pi by 7 I sin 4 pi by 7. Cos 4 pi by 7 plus I sin 4 pi by 7 is your third root. Likewise, for fourth root, we have to substitute n equal to 3, and we are going to get this one, 6 pi by 7 sin 6 pi by 7. For fifth root, we have to substitute n equal to 4, and we can get cos 8 pi by 7 plus I sin 8 pi by 7. For sixth root, we have to substitute n equal to 5, so we can get cos 10 pi by 7 plus I sin 10 pi by 7. For seventh root, we have to substitute n equal to 6. In this equation, we can find cos 12 pi by 7 plus I sin 12 pi by 7. So these are the 7th root we found by using de Moivre's theorem. Now we are going to go for another question, question number 27. By using de Moivre's theorem, solve this equation. Here from this equation, the higher power is your 7. That means we have to find out 7 roots for this equation. So to find out the 7 roots for this equation, you just rewrite this equation like take common x to the power 4 from these two terms. X to the power 4 taken common from these two terms means x cube plus 1. 1 taken common from these two terms means x cube plus 1 equal to 0. So here x cube plus 1 taken common from this and this term, these two terms, it will be x cube plus 1 into x square, x to the power 4 plus 1 equal to 0. So separately we can get the two equations, x to the power 4 plus 1 equal to 0, x to the power 3 plus 1 equal to 0. From this equation we can find 3 roots. From this equation we can find the 4 roots. Same procedure we have to consider to find out the 4 roots for this equation, 3 roots for this equation. Here you can see x to the power 4 plus 1 equal to 0. X to the power 4 will be equal to minus 1. See, minus 1 can be written as cos pi plus I sin pi. You can see cos pi value is your minus 1, sin pi is your 0. So instead of writing minus 1, we can write cos pi plus I sin pi. But in general, this can be written as cos 2n plus 1 pi. We know that cos odd pi always minus 1, and we know that sin any pi is the 0. So x to the power 4 in general can be written as cos. That means this equation x to the 4 minus 1 can be written as x to the 4 will be equal to cos 2n plus 1 pi plus I sin 2n plus 1 pi. So here, as the power is 4, we have to evaluate 4 roots. So for 4 roots, we have to consider n equal to 0, 1, 2 and 3. So now if x to the 4 will be this much, x will be how much? X will be cos 2n plus 1 pi plus I sin 2n plus 1 pi to the power 1 by 4. Now we are going to use the DMT for this equation. That means if we are going to apply the DMT, this 1 by 4 will be multiplied with this angle and this angle. So hence we found x equal to cos 2n plus 1 pi by 4 I sin 2n plus 1 pi by 4. By substituting n values as 0, 1, 2, 3, we can get the 4 roots. So first for first root, we have to substitute n equal to 0 in this equation. So it will be cos pi by 4 plus I sin pi by 4. Both are in the first quadrant, and cos pi by 4, I sin pi by 4. Magnitudes are same, 1 by root 2 plus I 1 by root 2. For second root, we have to substitute n equal to 1. 1 means this will be 3 pi by 4. 3 pi by 4 plus I sin 3 pi by 4. 3 pi by 4 means it cos 3 pi by 4 means it is in the second quadrant. In the second quadrant means cos theta is your negative, but sin theta is your positive. So we can find minus 1 by root 2 plus I by root 2. For third root, we have to substitute n equal to 2. If we have to put over here n equal to 2, this will be cos cos 5 pi by 4 sin 5 pi by 4. Cos 5 pi by 4 plus I sin 5 pi by 4. 5 pi by 4 lie in the third quadrant. Both are negative. So the value will be minus 1 by root 2 minus I by root 2. For fourth root, we have to consider n equal to 3. And here, if we have to put n equal to 3 over here, then it will be cos 7 pi by 4 plus I sin 7 pi by 4. And as 7 pi by 4 is lie in the fourth quadrant, then cos theta is your positive, but sin theta will be negative. So this value will be cos 7 pi by 4 will be 1 by root 2. Sin 7 pi by 4 is your minus 1 by root 2. So here I, so it will be minus I by root 2. So these are the 4 roots we have been evaluated. With the help of the same procedure, we can find the 3 roots for this equation. Cos xq minus plus 1 equal to 0, xq equal to minus 1 can be written as cos pi plus I sin pi. In general, it can be written as cos 2n plus 1 pi plus I sin 2n plus 1 pi. So as we have to evaluate 3 roots, so n values are 0, 1 and 2. So here xq equal to this much, x will be to the power 1 by 3. Applying DMT, we can find this one. Okay, to find out the 3 roots, for n equal to 0, this is the first root. N equal to 1, this will be cos 3 pi by 3 means cos pi. I sin 3 pi by 3 means sin pi. Sin pi we know that 0, cos pi is your minus 1. This is the second root. And for the third root, we have to substitute n equal to 2 in this equation, and we found the third root will be 1 by 2 minus I root 3 by 2. Right. Now we are going to go for our next question, that is your question number 8. By using de Moivre's theorem, that means DMT. DMT means de Moivre's theorem. Find roots of 1 plus root 3i to the power 1 by 5. This is somewhat different type of question as we discussed as compared with the previous 2 questions. So how we are going to solve it? First, we have to write this given question in the form of r and theta. Okay. So first we have to write the 1 plus root 3i in the form of cos theta and sin theta. Let this 1, which is your real part of this complex number, is your r cos theta. Root 3, that is your imaginary part of this complex number, considered as r sin theta. Now r square cos square theta plus r square sin square theta will be how much? Here 1 square plus root 3 square means 1 plus 3. And here if we are going to take common r square, this will be cos square theta plus sin square theta is your 1. So r square equal to 4, r will be equal to 2. Right. Now 1 plus root 3i will be written as r, that means 1 is considered r cos theta. So instead of r, we can put 2 cos theta. Here root 3 is considered as r sine theta. So instead of r, we can substitute 2 sine 2 and sine theta is there, sine theta. So 1 plus root 3i is written as 2 cos theta plus I 2 sine theta. If r cos theta considered as 1, r sine theta considered as root 3, so obviously tan theta will be r sine theta by cos theta, that is your root 3 by 1 equal to root 3, and theta will be pi by 3. So hence here instead of theta we can put pi by 3. So hence 1 plus root 3i will be, finally we can write 2 into cos pi by 3 plus I sin pi by 3. But we need to find out this one, the roots of this equation. That means 5 roots we have to find out. 1 by 5 means 5 roots we have to find out. So to find out the 5 roots, we have to write this one in general form. In general form, we can write 2 into cos 2n pi plus pi by 3 plus I sin 2n pi plus pi by 3, where n is your 0, 1, 2, 3 and 4, because as we have to find out only 5 roots, so only n values will be constrained up to 4. So here 0 for first root, second root, 2 for third root, 3 for fourth root, 4 for fifth root. And here 2n pi plus pi by 3, cos 2n pi plus pi by 3 will be same value as cos pi by 3. How it is, we know that pi by 3 means it will be 60 degrees. Suppose this angle is your pi by 3. So here n, if we are going to put 0 means pi by 3. If we are going to put 1, that means 2 pi plus pi by 3. So suppose this point lie on this line. So if I am going to add 2 pi, that means again we are going to reach at the same point. So if we have to put 2, it will be 4 pi plus pi by 3. So 2 pi, again 2 pi. We can reach at the same point. So cos pi by 3 plus I sin pi by 3 in general can be written as 2n pi plus pi by 3 sin 2n pi plus pi by 3. Now, as per the question, we have to find out this one, to the power 1 by 5. So 1 plus root 3i is this much. Therefore, 1 plus root 3i to the power 1 by 5 will be equal to 2 to the power 1 by 5 into this much to the power 1 by 5. Now we are going to use DMT, de Moivre's theorem. That implies this one will be equal to 2 to the 1 by 5, and this 1 by 5 will be multiplied with this angle and this angle. Cos 1 by 5 2n pi plus pi by 3 in plus I sin 1 by 5 into 2n pi plus pi by 3, right? Okay. Now here you can see this will be 6n pi plus pi. If I will take pi common, it will be 6n plus 1 pi. 5 into 3 will be 15. Okay, so cos 6n plus 1 pi by 15. If I am going to consider, if I will add this angle, we can find 2n plus 1, sorry, 6n plus 1 pi by 5 into 3 is your 15. Okay, now the roots are, to find the roots, the 5 roots, first we have to consider n equal to 0. For n equal to 0, we can get the first root. First root will be 2 to the power 1 by 5. Here you can see here we have to substitute n equal to 0. N equal to 0 means cos pi by 15. Cos pi by 15. Here 0 means sin pi by 15. This is your first root. For second root, we have to substitute n equal to 1. N equal to 1 means it will be 6 plus 1. 7 pi by 15. Cos 7 pi by 15 plus I sin 7 pi by 15. For third root, we have to substitute n equal to 2 over here. This will be 6 into 2, 12 plus 1, 13 pi by 15. Here also 13 pi by 15, sin 13 pi by 15. This is the third root. For the fourth root, we have to substitute n equal to 3. N equal to 3 means 6 into 3. 18 plus 1, 19. Cos 19 pi by 15 plus I sin 19 pi by 15. This is the fourth root. 2 to the power 1 by 5 is there. Okay. So here we found the 4 roots. Then fifth root, for the fifth root, that means for n equal to 4, we can find the fifth root. For n equal to 4. Okay. For n equal to 4, we can find the fifth root. Fifth root means x5, which will be equal to 2 to the power 1 by 5 whole into, if I will put 4 over here, this will be 6 into 4. 24 plus 1, 25. 25 by 25 pi by 15 plus, sorry, cos 25 cos 25 pi by 15 plus I sin 25 pi by 15. Okay, this is the fifth root, right? So if I'll be divide with 5, 25 and 15, then x5 we can get 2 to the power 1 by 5 cos 5 pi by 3 plus I sin 5 pi by 3. So 5, if I'll divide 5, okay. So this is the fifth root. So in this way we found the 5 roots of this equation by using DMT. Question number 29. Find all roots of 1 plus I to the power 1 by 4. That means 4 roots we have to find out. Here n will be considered as 0, 1, 2, 3, 3, up to 3. 3 means 4 root we can get. So this question exactly similar. Similar means here 1 by 5 is there, 1 by 4. That means 4 root we have to find out. Root 3 is there, and here instead of root 3, 1 is there. Similar, same procedure you have to consider and try to solve this question by yourself. I left for you. Next question number 30. Find all roots of x to the power 5 plus I equal to 0. This is another type of question. So here x to the power 5 in the equation is there, means we have to find out the 5 roots. Okay. So to find the roots of this equation, first we have to write the given equation is this one. X to the power 5 will be minus I. Here minus I can be written as, carefully you have to observe here, cos pi by 2 plus I sin pi by 2. Cos pi by 2 is your always cos any pi by 2. That means cos any odd pi by 2 will be 0, that we know. So cos pi by 2 minus I sin pi by 2. Sin pi by 2 is nothing but 1. So we can get minus I. So instead of minus I, we can write cos pi by 2 minus I sin pi by 2, right? But as we have to find out 5 roots, so we need to write this one in general form. In general, x to the power 5 will be equal to, that means minus I can be written in general form as cos 2n pi plus pi by 2 minus I sin 2n pi plus pi by 2. So here n can be taken as any integer, 5, 6 and so on. But as we have to consider, as we are we have to evaluate 5 roots, so up to n equal to 4 we have to consider. Okay, here you can see, if we are going to consider n equal to 3, so this will be how much? This is 6 pi plus pi by 2. 6 pi plus pi by 2, that means here 6 pi plus pi by 2 means 12, 13, 13 pi by 2. So any odd pi by 2, cos any odd pi by 2, we know that is your value is your 0. And here 13 pi by 2 value is nothing but your 1, right? You can see here 13 pi by 2 means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So here is in the first or second quadrant, you can say sign is positive. So sign positive means pi by 2. The odd pi by 2 of sign which is in the first or second quadrant, the value will be 1, so it will be minus I. Okay, now we are going to use the DMT. Sorry, here x to the power 5, if it will be this much, so x will be this much to the power 1 by 5, and here n, as I told that we have to consider up to 4 to find out the 5 roots. So by DMT, this one will be written as, this 1 by 5 will be multiplied with this angle and this angle, cos 1 by 5 2n pi plus pi by 2 plus, sorry, minus I sin 1 by 5 into 2n pi plus pi by 2. So we just add these two angles, we found how much? This will be 4n pi plus pi, that means 4n plus 1 pi, 5 into 2, 10, minus I sin 4n plus 1 pi by 10. Now we are going to find out 5 roots from this equation. by substituting n equal to 0, 1, 2, 3, 4. For n equal to 0, here you can see this will be cos pi by 10 I sin pi by 10. This is your first root. N equal to 1, put 1 over here. This will 5 pi by 10 sin 5 pi by 10. 5 pi by 10 means 5 pi by 10 means pi by 2, right? That means cos pi by 2 minus I sin pi by 2. Cos pi by 2 0, I sin pi by 2 will be minus I, because sin pi by 2 is your 1. Likewise, for third root we have to substitute n equal to 2. N equal to 2 means 8 plus 1 9. 9 pi by 10 cos 9 pi by 10 minus I sin 9 pi by 10. For fourth root we have to consider n equal to 3. So this will be 4 into 3, 12 plus 1, 13 pi by 10 minus I sin 13 pi by 10 is your fourth root. This is third root, fourth root. Similarly, for fifth root we have to substitute 4 in this equation. N equal to 4, we can find fifth root, that is your x5 equal to cos 17 pi by 10 minus I sin 17 pi by 10. Okay, so here we have to stop our today's lecture. In our next lecture, next class, we are going to discuss functions of complex variables. So thank you so much for watching this video. Thank you.